describe any data and the resolvers are just a function, usually it's been just very easily set up on top of our existing APIs. But then, once it's set up and we got a lot of the benefits and everyone is happy, then comes the next phase, like what do we do next? And for us, what we see a lot is that the GraphQL team usually is struggling to actually call the downstream services, because those are the same downstream services and the same issues are also there. Like, those are services that are not typed, we still need to go there and we still need to figure out what the hell is going on there. And when they break, like we have, with GraphQL, we have like, we can prevent from breaking changes and all the cool stuff that we also know. But if the downstream services are breaking, they will break us anyway. So what we started in the process in the guild is starting to looking at those downstream services the step after. Because usually when companies are calling us or like are contacting us is after they already implemented GraphQL, and then they want to move to the next phase, and then it's the more, let's call it the next phase problem, after you're already using GraphQL and you're happy. So some approaches of how to deal with like those backend services, some of them are like, let's just rewrite them all into also GraphQL, make everything GraphQL and everything will be great, let's be a GraphQL maximalist, everything GraphQL. And that's, might work in some companies. Another approach is maybe to build like small gateways or like small like servers or small proxies of GraphQL on top of the existing things. And those work. There's plus and minuses on all of them. Usually I talk a lot in this slide, but I think I'll skip and then we can also have a discussion at the end, just in terms of time. But as we went to approach the problem and we did it again and again and again, what we started thinking is like, what do we actually want from GraphQL? And some of the things is that we wanted a predictable schema to understand what is the actual data that we can query. And also we wanted a query language and an engine, so we can ask and send a query to that. And we're not working in a void, right? Like if we look at the existing backend services, they work and they're there. And usually, like when we look at most of our customers, like those services we can say that are, they're not the best, but they work. So what do we have there? Maybe we have an open API schema. So we have some kind of schema of the data that is there. Maybe it's a gRPC that also does validations, and we know that the schema actually equals to what's going on there. Maybe you have nothing. Maybe it's a REST API without anything, but we do have logs and we do have information about what's going on. So what we thought was, can we look at all those existing things that we have that are not giving us the right guarantee like GraphQL gives us, but it gives us something? And can we somehow shorten the way for us to get to where we want using those existing tools? So the idea was, can we look at all existing schemas that are not GraphQL, or something else? Or maybe look at live data, understand from that live data what actually is happening, and then get those schemas, and then from those schemas just translate them into GraphQL representation. And that's GraphQL Mesh. So, and again, GraphQL Mesh, you can think about it as a concept again, not as the library itself, like there's many other implementations, but first of all, the first idea is query anything. Like we can take any source, kind of like what GraphQL is, right? GraphQL is just a function, and there's we can query any function. But in this case, we can take many different existing protocols like OpenAPI and Swagger, OData, gRPC, SOAP, or maybe JSON schema, which we can generate JSON schema from actual just traffic. Then can we take all of those, let's say in our case, OpenAPI schema, and with some configurations of letting Mesh know where it comes from, generate a GraphQL implementation, a GraphQL schema. Another example is like, this is just like an example network request. From there, we can generate JSON schema, and we can feed that into the Mesh config, and then that will also print us a GraphQL schema. Here is another example. Like we have two GraphQL APIs, two GraphQL sources. One is for countries, one is for like cart, and another one is Stripe. But Stripe is not, it doesn't have a GraphQL API. But now it does, because Stripe has an open API schema. So now we just add it into Mesh and we have three existing GraphQL sources. Like we can just have three schemas that we can just send queries to, even though they're not GraphQL at all. So that means that now clients or consumers can work with services that are not GraphQL as if they were. We can send a GraphQL query. I can talk even deeper about how we're technically doing it. Like we're not actually making a regular GraphQL execution. We're actually making it more optimized. For each of these handler, we have executors. So we make it in a more optimized way. But basically, I can send a GraphQL query to basically a service that has nothing to do with GraphQL, has no idea what GraphQL is. And the main idea was, let's take the best out of GraphQL using our existing services, and we can still use the original protocol that exists out there for many reasons. Like maybe converting this service to GraphQL was better theoretically, but everyone has work to do, and maybe even in many cases that we saw, the teams there, not only that they don't care about GraphQL, sometimes they don't exist. Right? Those are just services that nobody wants to touch anymore. And then the next thing is like, once we took all those different sources and we made them into a GraphQL representation, which is by itself a very interesting thing, because now we can store all those different schemas in one place, and now even just the conversation inside of the organization is all around a GraphQL schema. It doesn't matter if your source is a SQL database or an open API or a GraphQL service, we all talk in the same language. So, but once you do that, then we can do the next step, which is to merge them all into one single graph. Now, I'm not going to open the debate here into, do we want actually a one single graph or multiple single graphs? Like, I have a lot of opinions about that. We can talk about it for 2 hours. But you can turn them all into one single graph or multiple graphs. So you can merge all those different sources together. So for the consumer, that means that for them, it feels like they're querying one single source, but at the end of the day, they're querying multiple sources. So it's a very, very powerful idea. And there's many different features. I'll skip some of them now, but once you have all those different sources, we also added all kinds of features like changing automatically naming conventions. For example, let's say you're querying a soap service, and in soap land, like everyone is doing everything capital case for whatever reason. Let's not fight about it. But the good thing is that we can now change it. So they can go and do their capital case, and then we can automatically change the naming convention for the consumer. So the consumer can we can automatically convert their into a camel case or whatever you want. We can also do some modifications in the configurations. So that means that I can not only query many different sources from many different technologies, I can also adjust them. And that means that I have a config that shows what I want, and then the provider actually, they know what I actually need, which is another very powerful idea. So in GraphQL, the title of GraphQL Mesh is query anything that we just talked, but also run anywhere. And then the run anywhere, again, look at it as like a separate idea. The idea of run anywhere is that in the case of Mesh, we take all those different sources, we do those translations that I said, but this is a completely different step than the execution. What does that mean? It means that we take those configurations where all those different sources are existing, where are all those different schemas that we want. We can add custom resolvers, we can add all these transformations, and then we can build that. We do a build process that we can build or a gateway, that can run in the center of your organization and everything will run through it, or we can actually build it into an SDK. And that SDK can run anywhere. So that means it can run on your client. So we have many, many companies that for whatever reason, they're not ready to actually introduce a GraphQL gateway yet. So we take everything that I just showed you and compile it into an SDK. So over the network, or in terms of deployments and runtimes, nothing changed. It's just that the developer experience for the consumer, they feel like they're querying one single thing conceptually, but at runtime, they're still doing REST requests from the client to the server. And it's amazing how beneficial this thing is if we even put aside all the performance benefits of GraphQL.
Oh, wow.
So yeah, like I said here, like you can run mesh, or again, you can think about this theoretical solution as a central place, but you can also basically take all those things and compile it per even service. Like if you have a service like a machine learning service or that needs to query many different other services, the developers of that service will feel like they're querying one single place. But the people that are actually responsible on runtime and reliability and everything, they don't want to introduce a new central service. So we can just introduce it as an SDK. And then specifically in the GraphQL mesh part, we use JavaScript. But we built also an internal library, we also open source, and that's also something we brought to the REST world and the regular JavaScript world, is we built a library that basically abstracts away all the different JavaScript runtimes. So that means that not only that you can take that SDK, and that's true for any library that the guild is building, not only that you can run it on the client or on a node server, you can run the same code on BAN, Dino, Cloudflare workers on Edge, any place. And you don't need to change any code. Now, if we take that step further, we also have plugins into Mesh. So let's say one plugin is like response caching. Now, here is like an example configuration. So I'm taking a regular API, like a REST API. I'm generating JSON schema from it, and some example responses. Then I generate GraphQL API from it. And then I'm deploying it into Cloudflare workers, and I'm putting the cache into Cloudflare. So now that means that I took, just with this configuration, I took like an old REST API, and now I have a GraphQL API with caching running on Edge. And again, there's a lot of questions of caching, where do you want to do it, and where it's beneficial, but for many, many applications, running the caching and the storage, like using D1 or many other cases of storage on Edge, like you can get really significant performance improvements. I had a really interesting talk with a couple of people here that they need to serve their application in China. And then they had a lot of issues, performance issues there. And this thing was very beneficial for them. It also depends, of course, on the use case, because you still need to get to the original server, but yeah. Also conceptually, this is another library that we built. We have GraphQL, let's say we took all of that, we get the GraphQL service, or you can use your existing GraphQL server. What we've done is also the other way around conversion. Like many companies, they introduce GraphQL API, but they still want to, let's say, expose a REST API for, let's say, third-party partners, or maybe another team that is not on board the GraphQL hype train. So what we thought is like, can we, in our minds, GraphQL is kind of like a superset of REST. So can we maybe generate from our existing GraphQL APIs, can we generate REST endpoints? So we did. And that library is called SOFA. So now all this, the main point that I'm trying to make here is like, all these boundaries between GraphQL and let's compare GraphQL versus REST, GraphQL versus whatever, we don't think about it like that. We just think the fact that we can translate everything into GraphQL and the other way around, we suddenly started thinking about abilities, specific features that we want from GraphQL, and how can we start using them without coming to an organization and say, let's migrate everything to GraphQL, which usually is not the easiest thing to do. I'll try to keep it short and I'll just finish soon, but I just wanted to say that now that we think like that, we can take more abilities from GraphQL and tools even for GraphQL and bring that into the API world. So, like I said at the beginning, one of our main issues was that we worked with clients, they had GraphQL APIs, but their underlying teams kept breaking them. So the REST API teams kept making changes, and even though GraphQL protects you from breaking changes, the sources made breaking changes, and then nothing helps. So, when we knew that problem for GraphQL, we have GraphQL Inspector, which is a tool that statically runs on your schema and makes sure that you're not making breaking changes. This is all kinds of cool features that it can do, but that's basically the premise of it. And then, so that's one thing. The other thing is, like, let's say, even if we do prevent breaking changes statically from different versions, sometimes we want to also prevent changes based on usage. So we need live data. And that's, in GraphQL, there's Apollo Studio, and also we introduced Hive, which is like both of them are schema registries, but also that are looking at your usage. So they can tell you, okay, you made a breaking change, but nobody used that field for the last 30 days. That's fine, you can make that breaking change. It's kind of like Google Analytics for your APIs. So all those things are very powerful features. I'm going to skip the example here, but you should definitely check out both Apollo Studio and GraphQL Hive. But all those cool features that those tools are giving you, now with the help of Mesh, that you can take all those things and convert it into GraphQL, you can bring those into OpenAPI. So what we've done as a first step, we went into the teams that we were querying, the REST API teams, and we just placed Mesh and Hive into their CI/CD. So now we failed their CI/CD when they were about to break us as the GraphQL consumers. And that's, I think, the main point here. Like, we used GraphQL tools in an environment that is not GraphQL to get some of the benefits of it. And those were very, very beneficial. So the my main point for today was maybe don't think GraphQL, just think APIs. And try, if you're in a larger organization and you can't rewrite everything from scratch, try to leverage what you have already. I know every developer hates the code that they inherit, but in this case, maybe try to work with it. And gradually evolve into that perfect situation where, if you think that everything GraphQL is the perfect situation, gradually evolve there. And use all kinds of tools to take the stuff from GraphQL into the other API world. That's it for me. There's many different, who is after me in terms of schedule? You? Okay. So I'm really excited for your talk. I'll just say that in the guild, everything that we build, every library is under a person. And the main person that worked on GraphQL Mesh and did all that work is Arda. So I wanted to mention him, and you can follow him on GitHub and Twitter. And I'll just mention again, first of all, the event next week. If you want to join in Berlin, if any one of you want to get a free conference day. And most importantly, GraphQL Conf. I highly, highly recommend you to join. I think it's going to be really exciting there. So thanks.